Hi, I'd like to talk a little bit about a magic trick, and magic trick is a little variation on the old ball and cups. In the old days, they'd take a ball, cover it with a cup, and play the old shuffle game, and then go, hey, which cup is the ball under? And maybe there was a sleight of hand such as that. But we're going to do a little variation because this is chemistry involving water. So I've got 3 empty party cups, and I'm going to pour water into one of them. And put some water into there. And the idea is I'm going to shuffle these cups and find out if you can keep track of which one I poured water in. So there was no cutting of the film. And how many of you think that it's in this one? Think it's in this one? Think it's in this one? Let's try this one first. No, there's no water in that cup. Think it's in this one? No, it's not in that one. Think it's in this one? No, it's not in that one. So what happened to the water? Where'd it go? There's no water in these cups. There was no cutting of the film. It turns out that, yeah, this had the water in it. Before I started the trick, I put a little bit of a powder in here, and it's called super absorbent polymer. That's its name, super absorbent polymer. And polymer is very much in line with a plastic, and this is the polymer called super absorbent polymer that's used in diapers, your disposable diapers. So when a baby goes ahead and urinates and sucks up all that absorbent stuff and holds it away from the baby's skin. So when I poured the water into here, super absorbent polymer absorbed a bunch of the water, and it's sticky and holds on to it. So pretty neat. We'll talk about what polymers are right now. The word polymer, of course, is 2 words put together, poly meaning many, and mer actually meaning units, so many units. Maybe you were bored when you were a kid, like in a history class, and you take the little paper clips, hook them together and make paper clip necklaces. Well, you were making a polymer, many units. Not on the molecular level, but with paper clips. What we're going to do in chemistry over here to the right is take some compounds. This one is called compound A. This one's called compound B. And we're not going to hook A to B. We're going to hook A to B, to another A, to another B, to another A, to another B. We're going to link them back and forth, A, B, A, B, A, B, billions and trillions of times. The idea here is one of these molecules has 2 hands. A hand on this side, meaning something that'll reach out and grab, and a hand on the other side. And if you only have a molecule with 1 hand, you can hold on to something and that's it. Can't go any further on this side. But by having 2 hands, you can link together. So one of these is going to have a B on the right and a B on the left. And one of these B molecules has got 2 hands, and it's going to have an A on the left and an A on the right. And they're going to alternate back and forth. Turns out that this functional group, as we call it, part of the molecule here that goes COOH, is called a carboxylic acid group, COOH there, and it has the word di out in front because we've got ourselves 2 of them. This is a dialcohol. This doesn't have COOH, it just simply has an OH attached to a carbon. There's no oxygen up there with the double bond. This is the alcohol group, so we call it a dialcohol or a diol. And the reaction happens when these 2 get together and water is eliminated. This carbon over here is going to form a new bond to that oxygen, and that OH on this molecule and the H here are going to leave. You can clearly see that that's water, H2O. We call this a condensation reaction because condensation means the removal of a small molecule. Like when water comes out of the air and situates itself on a cold glass of iced tea, you would say a condensation. So water leaves. So when these 2 react, we're going to make A, B, A, B, A, B. And it's going to make a long strand. Turns out that when we go ahead and make this, we're going to make a long strand, and it's very similar to the material that they like to use when making things like, backpacks and disco slacks and all sorts of fabrics. So make a polymer. We can make another polymer type. It's called a radical polymerization. Now, a radical has the symbol of big R with a single dot because a radical has an odd number of electrons. For a radical, I give a nice example of this, and it's not OH minus, it is OH, meaning that it doesn't have an extra electron and it has an odd number of electrons. 2 here in the bond, total of 7. This is very reactive. What it's going to do is it's going to come right out in front here. It's going to attack the carbon. It's going to take an electron out of this pi system and move it out in front and form a new bond. So this electron and an electron here will come over here and form 2 electrons in a bond. That's going to leave an electron here in this bond to move out in front, and we have not solved the radical problem. We just have a bigger radical. We have this, and we still have an electron out in front. Now, nobody in the polymer game is going to take one of these and react it with one of these. You're going to take this stuff, mix it up in a pot. You're going to use a little bit of this and a whole lot of this. It's called ethene, or ethylene is its common name. And when we put it in a pot, we're going to use a lot of this. So what happens is one of these starts a chain reaction with this. This still is a radical. Another one of these ethylene molecules will be attacked. And another one, and another one, and another one, until literally thousands, millions of these all line up in a row. And you're going to make a long strand, or a polymer. Now, philosophically, questions can be asked like, when does it end? Well, another one of these radicals could come up, or 2 chains could be building inside the pot, and then bam, they hit each other and neutralize. We don't want a whole lot of chains going, otherwise these will end up really short. So, an introduction to polymers. Polymers are plastics, little water bottles, things like some disposable materials like a comb and a toothbrush. And these actually came from a prison. I toured a prison with my son in Cub Scouts, and they gave us these little items, and of course they're polymers, something really soft and flexible so that they couldn't be made into like weapons in a prison. So, I hope you've enjoyed the little trick and introduction to polymer. Thanks.